Hi everyone, this is our video for the ME190 term project. My name is Harpinder Dylan.
I'm Alex.
I'm Justin.
And we decided to do our project for the Spartan Superway bogie, so they were in need of a control system suspension to control the elevation of the bogie as it changed elevations on the track. So we will present a video on how we made a small scale model of the system and describe our control system and kind of go through what our performance is and some of the improvements that we would make for future project implementation. Go.
All right, so our design right here, we basically use SolidWorks to create it and model it and see how it would work as an assembly. And we use 3D printing to make lightweight materials so we can use a small servo to lower our costs. And so let's take a look at what our hardware is. So right here we have a 3-axis accelerometer, and we have our power source right here, and we have our Arduino microcontroller, and we have a 5-volt servo. Also right here is our rail system. So this is the rail that has the solar panels on top and everything. Here's our bogie, our platform, and a link. So the servo, by rotating, is going to control this link, and it's going to rotate this platform to an angle we want, which is the horizontal angle.
Go.
So this is the Arduino code that we use on our project. As you guys can see, we initialize all the variable needed, the KP and KD value. We make an object from the PID class, PID library. We set it up. The calibration function here is to calibrate the accelerometer value, so we know where 0 is, where the platform is horizontal. And on the void loop, we set the point to equal to 0, which is the horizontal position that we want. Input here will read position. In the read position function, we read the position of the accelerometer value. We calculate it from a bunch of analog value. We convert it into a value that we can use. So back to the main loop here, we use the compute to calculate the input from accelerometer to be an output for the servo.
Here the bogie is at the horizontal position, which we're going for. So if we tilt the rail, the bogie should adapt to that and stay horizontal. The only problem is we don't have much range on our servo motor, therefore we can only tilt the rail so much. So there it's settling at its horizontal position. If we go the other way, so we do have some noise, and our noise is actually from our servo motor, or actually from our accelerometer. So our accelerometer is outputting values, just noise values, and that's causing the servo motor to react to that. Also, when the servo motor is tilting, it's causing acceleration in the accelerometer, and that is giving us more noise, and those values are causing it to not settle, even though our PID controller should be settling, because we did our calculations in MATLAB.